we're going to talk about some sports science, specifically why do balls bounce?
Why do balls bounce?
Well, balls bounce because they have a special property called elasticity, which means, what it pretty much means is that when the balls hit something, they bend and deform rather than cracking and breaking. So if you think about it, we're going to talk about how when you press a ball, it deforms, and if you pressed a piece of glass, it would crack in half if you dropped it. So the experiment today, we're going to look at some different kinds of balls and how they bounce differently, and depending on what kind of ball they are. So we have some hollow balls. We got
two hollow balls.
Actually,
three hollow balls.
Three hollow balls. We have a small playground ball, a tennis ball. We have a ping pong ball, and even though they seem like they were deformed,
this one bounces.
They bounce. And then we have a solid core rubber ball, or else a super ball, like you would know. So Mary's going to go up on the ladder, and we're going to test and see how well they bounce.
I know, so elasticity, the deformation, helps make balls bounce.
Right.
But this isn't bouncing.
No, that is elasticity, but bouncing is Newton's third law. We're talking about those again. So the third law, it means that any action force is met with an equal and opposite reaction when they collide, like that. So the ball collided with the ground caused the force to shoot the ball back up. Balls bounce higher or lower depending on how much they deform too, and what kind of materials they're made of. So let's see what happens. Let's start with the playground ball. Okay, so we saw that it hit a little bit up. We're going to do some slow motion, and you can see how the ball bounced. Okay, now we're going to try the tennis ball. And let's see that in slow motion. Next, let's try the ping pong ball. And let's see that one in slow motion. Last, let's do the solid rubber ball. And let's see that in slow motion. Let's compare the bounce heights. So our first experiment was Mary dropping the ball straight down, and we saw that it was an equal and opposite reaction. The ball went straight down and came straight back up. Now, that doesn't work well for sports all the time when you're playing with a team sport. So there's a reason that you would try and bounce the ball towards somebody. Angles count. So as Mary throws the ball at an angle down to the ground, it's going to bounce back up in the exact same angle to me. Let's see if that works. Yeah. I'll try it now. And that was too straight. So my angle was off. Let's try one more time. Yay! Mary, come on.
Hey, we learned this at carnival.
Yes. Yay! So that was some really cool experiments.
Yeah, and we learned elasticity is important in bouncing for the equal and opposite reaction.
Exactly.
We also learned material counts too, because we noticed in that comparison shot with all of them bouncing next to each other, that one particular ball didn't get quite as good a rate of return. Like it didn't bounce for as high for as long as all the other ones. And that was the ping pong ball, because its material is more rigid or less elastic than the rubber-based balls.
Right. So if you have any balls at home, go ahead and do your own experiments. Do them inside, do them outside. It's a lot of fun to play around and see what different balls will do.
Yeah, and if you want to look more into Newton's laws of motion, make sure you check out our stream material available in the library or in our online resources like Hoopla. So we'll see you again at another Stream Thursday. Bye.